Good morning, everyone, and welcome to our webinar on advancing sustainable bio-based systems from safe design to circular end-of-life solutions, which is organized by BioPhenom project, and it is being held with valuable participation of OlinWaste, SuperBark, CUBIC, and BioSUSTEX projects. The webinar is organized in two different series. Today, we will talk about implementing safe and sustainable by design, while the next part of the webinar will be on the 8th of July and will focus on side streams and end-of-life strategies. Some quick practical aspects before we start. There will be a Q&A session at the end of the webinar after the presentations. Participants are asked to type their questions into the chat, indicating which speaker they are addressing their question, and we will take those questions at the end of the webinar. Also, this webinar is being recorded, and the recording, together with the presentations, will be shared afterwards on the BioPhenom project website. You can find the link in the chat. So after this short and quick introduction, I would like to give the word to our first speaker, Barry Hardy from Edelweiss, representing BioPhenom project, who will talk about an evidence-based workflow approach supporting SSBD goals for chemical and material designs. Barry, the floor is yours.
Let me know if you see a slide
Yes.
on the screen. Okay.
Yes, thank you.
Well, hello, everyone. My talk today is going to focus on what an evidence-based workflow approach is for supporting safe and sustainable by design goals. And we're developing and applying this approach on the BioPhenom project and some other projects too. And of course, in the BioPhenom project, the chemicals and materials are coming from bio-based sources, such as from forestry and agriculture. And our potential ingredients for bio-based plastics or composites that would then be potentially incorporated into components in different industries, like a car part or a contribution to construction material. And the project is about investigating the potential for these bio-based materials in terms of the knowledge we have on them, both background knowledge, new knowledge we generate in characterization and testing, and trying to build up the evidence package on whether we have a good candidate substitution for any particular product. And with that, that's the basis of my theme, that this needs to be evidence-based and the knowledge needs to be organized in a structured manner that then comes into a workflow in which we make decisions on as we build up the knowledge and come to a decision which may be an intermediate one and help guide new work, or it may be a final decision whether such a bio-based material can go forward to the market or not. And this approach is tiered. BioPhenom is still at a relatively early stage. Most of the work is currently internal, generating new data, so it's at an early stage in terms of results. In the initial first tier, one looks at all available background knowledge to help guide the work, and then in subsequent tiers, further experiments and analysis is done to get to downstream decisions. So we should, with this evidence-based approach, always have well-documented the workflow for any particular decision associated with any particular decision gate. It's one of my main messages, and we should be able to go back to that 3 years later and understand any decision we made. And supporting that, we need to organize the knowledge in a structured and harmonized way, using templates, using any available ontologies we have, having provenance and version control on any evidence or data set we used in any particular workflow, and integrate that evidence into from various sources, from hazard through to life cycle assessment and end of life cycle, into a relevant evidence package, which may in the future increasingly be used in regulatory decisions. But for a good business decision, we need to take an evidence-based approach as well. Now, contributing to that, we're not starting from scratch. So one input is the OpenTux 2.0 framework, which we recently published, where we went into the principles on how such knowledge, data, predictive models, and their validation should be organized, and also a quite considerable section on the principles of using AI in going about that kind of work. And although this is mainly in the context of risk assessment, I think a lot of the principles apply to SSBD. We're also starting with principles we put into practice with knowledge infrastructure in the area of next generation risk assessment, where basically, yes, you have to organize the data, but you also have to document your pipelines and processing and analyzing that data and any methods you used, whether they're experimental or in silico. So we're bringing that knowledge infrastructure into supporting the BioPhenom project. And also materials characterization. We need to bring into account the different kinds of physical chemical techniques and biological experiments you would use on materials. And again, we're not starting from scratch, so we're integrating the tools and resources we developed under the Accords project. Some example here from the BioPhenom project of implementing that is that from the start of the project, we're documenting in a protocols database all protocols used on the project in vitro and in silico, so including SSBD analysis. And on the workflow approach, we're basing it on this ASPA workflow approach, which was developed within the Risk Hunter project, just recently published. And the idea is for any problem formulation, you have a well-defined, reproducible workflow to get to an answer. And that workflow may also have workflows underneath it. It may lead to further workflows. And in the end, you will have a set of tiered workflows that document all the work you've done to come to a risk decision. And our work related to BioPhenom is extending this kind of workflow approach to SSBD, bringing in the additional tasks and workflows to following this kind of scheme, and the extensibility looks promising so far to do that. So the ASPA documents the workflow that you followed. What data did you use? What knowledge did you use? And while doing that, we can use AI to assist various tasks like creating or completing templates or automating the building of knowledge graphs. And so the AI can assist us in doing the work in these kinds of workflows. As examples, and we've shared some tools publicly that you can consider using. So in a first tier SSBD, you want to bring all available background knowledge. So these are tools that mine the literature and bring that data into the database, or mine and retrieve data from chemical databases, and with, again, with integrity and referencing. And the AI can assist us in these kinds of tasks. This is another tool we built. We also made a public version of this available for collecting all the different safety data sheets from different suppliers and mining them and bringing the data on from the safety data sheets, whether it's from documents, into a structured form into the database. We need an end user software, so we have a software called Smart Safety that we're extending to SSBD, and there we organize the information on both ingredients and formulas and compositions, so we can look at assessing the information both on ingredients or substitution ingredients, but in the context also of the formula, because in the end, the formula is the product or the material in the product. And here's one example of an algorithm there that fits well into a first-tier approach in that you can look at an environmental scoring from different perspectives like persistence or mobility on different ingredients and their alternatives, and that can help you make a better SSBD decision. And this is quite quick, and you can do it maybe consider what the parameters are you're using, but you can do this quite quickly. Another example of integration of knowledge is shown here, in which we, within the Safer Skin application, we've integrated being able to compare different kinds of predictive models and get those results for any ingredient and compare them. You can also add experimental information using certain algorithms like Bayesian and get an updated prediction when you have more experimental data. And we've integrated those models through this application through interfaces into the smart safety application, so they can be part of the SSBD analysis there. Rather than carrying out hazard calculations in a spreadsheet, which have low integrity, we've built workflows to do the first tier characterization, which is based on existing knowledge and data. But then this also can be extended when further experimental work is also needed, and would then add experimental workflows. This one is a computational workflow, so the ASPA would document the workflow, but you also have to build the computational workflow to bring the data together. And of course, we also have to do this in other areas, such as in looking at environmental sustainability and against processes when we look at life cycle analysis. But again, the different kinds of integration of data should be carried out in a similar way. On background knowledge, it's quite difficult bringing different kinds of knowledge together. So we built a couple of tools over the last year that bring different kinds of knowledge on adverse outcome pathways to give you a model, a network model, which is basically a knowledge graph, against which you can analyze your data, both background data and data generated on the project. And we've also made a couple of versions of these tools available, like this AOP Graph Explorer semi-automates bringing this knowledge together, builds your knowledge graph for your network model. We have a couple of additional tools that allow you to look at data then against the model and visualize them. So we also made a public version of this available too. If you go to this preprint, you'll find out where the tool is. Cross-species modeling is another area we've been working on. Your compounds may have different effects on different species, different life stages in the environment. And so here, what we try to do is bring model from different species together and look at the impact across species and the variation across species in the environment. And you can extend this also to including human and mammalian data too. So in summary, we're looking at how the combination of a fair knowledge infrastructure, data and models, background knowledge and experimental data can be brought together as evidence, well-documented evidence, into workflows organized in this ASPA-based way that would help you document any particular decision against a particular problem formulation that can then be building up a history, a memory of everything you did to get to every particular decision gate and no-go decision. And just emphasizing again, what I tried to show here is You may use a variety of tools to bring that knowledge together. It should be standardized. It should be versioned. It should be harmonized as best one can. And that's the difference between having data and unstructured knowledge and having an evidence package. One topic that we've been working on, which I find is, I think, in my opinion, quite important for SSBD, is while doing this, you often find conflicting evidence. So how do you deal with that in your decision making? So we've been trying to develop protocols that would allow you to document how you came to a consensus decision, even if you had a mixture of positives and negatives. You could document your current decision and proposals to improve it. And that should be a protocol itself as a sort of weight of evidence protocol for conflicting information. I have an initiative on that called the Open Model. And the idea there is to have a repository which would be community-based, where we're open about such protocols and templates and can share them. So if you're interested in that, please contact me. So in summary, we're putting together workflows with AI assistance to human work and of course, learning loops. It can be supported by knowledge mining. Whatever method we use should be well documented. Knowledge graphs are helpful, and AI can help us build those graphs. We need to bring the knowledge into assessment tools and then compare the results. And like I just mentioned, sometimes we have to deal with conflicting results. We may get different results from different models. Hold on a second. And that was my alarm bell for finishing. So I think I managed to get through everything. I must of course acknowledge all the partners here, the funding from the European Union. We work a lot on the SSBD with Panos and the group at Luxembourg at least. And of course, a lot of interactions with the other partners are really needed to make such an approach work in practice. So thank you for your attention.
Thank you very much, Barry, for this really interesting presentation. Just a quick reminder for the participants. If you have any question, you can type it in the chat, and we will take those questions at the end of all the presentations at the Q&A session. So feel free, even now you can start typing your questions. And now I will give the floor to Panos. Panos Isigonis from LIST, who will who represents SuperBark project. And Panos, the floor is yours for your presentation.
Thank you. Thank you, Melinda. Hi, everyone. Good afternoon. I will have the pleasure. First of all, thank you, warm thank you to BioPhenom project for inviting also SuperBark. We are very closely related projects, and we are happy to share our insights from the SuperBark project on the application of safe and sustainable by design. In our case, to bio-based adhesive and coatings development. So obviously, you see here the main partners: LIST, VTT, Riga University, ICP Technalia, and Holzforschung from Austria. But the work on SSBD involves the whole consortium. So a few words about the projects for those that they are not familiar. SuperBark is a medium, let's say, size consortium of 12 partners from 8 countries. The project is coordinated by VTT, the biggest RTO of Finland, and it is funded under the Circular Bio-Based Europe joint undertaking. It's a 4-year project, which is multidisciplinary, as it brings many different fields of expertise together, and this is where safe and sustainable by design comes as an activity, trying to put all the different aspects of technological development into under one umbrella. Now, very few words about the scope and the solution, because this is important to understand what the SSBD is trying to support. So the SuperBark is about the development of bio-based adhesive and coatings with more than 95% bio-based content from industrial softwood bark. And then there are different applications in wood and paper, as you can see also on the screen. Some example is plywood, MDF, and coatings for packaging paper and so on. And SSBD, of course, is related to improving the environmental and safety performance alongside the recyclability. So obviously keeping in mind the functionality for the industrial applications, but also taking into consideration these aspects. These are the main objectives of the project, which of course the main one is to develop the bio-based adhesive and coatings, but we also want to apply safe and sustainable by design to support the design of those adhesives and coatings for the bar components and ensure that they are safer and more sustainable than benchmarks materials used currently in industry. Of course, SSBD, this is common for many of the projects that they are working on safe and sustainable by design. It is usually a supportive work package that is collaborating with all the technological partners in the development of the materials, and then receiving and providing information. And in the SuperBark case, we have, as I mentioned, two roads that we follow. One is about adhesives, the other one is about coatings, and we try to support both routes with our work. Now here, for those familiar with the SSBD framework and also the revised version that came out at the end of 2025, here we try to show where the main activities of the SuperBark project related to SSBD are placed. So we do have the usual, let's say, activities about safety and sustainability. Of course, the project was written before the revised version of the framework has been introduced. So you see here in the updated figure that the scoping analysis and the SSBD scenarios are integral parts of the circular iterative approach of the SSBD framework, but we do not cover everything in SuperBark because this was not part of the framework, but we have adapted as much as possible our activities. And you can see the flow chart of activities that we follow. So of course we have safety and sustainability criteria, and we have different tasks with different activities related to safety, sustainability, techno-economic assessment, recyclability and biodegradability, and then we try to integrate the results of all these activities in order to have informed decision making. This is, of course, not to go into full detail, but just to show you, this is very common in many research projects that implement SSBD. We try to cover all the aspects that I mentioned before. Of course, set up the methodological basis and then perform the assessments of environmental sustainability and chemical safety, and then take into consideration other aspects such as techno-economics, recyclability and biodegradability. And you can see some of the main activities for each of these tasks within this slide. Now, what is important when we try to apply the SSBD framework, because every activity is different and then there's no golden rule, we try to adjust the suggested SSBD framework to the SuperBark cases about the bio-based adhesive and coatings. And then we have reference materials, so urea formaldehyde and adhesive, for example, they are being replaced by bio-based polyphenols and CNF, and then PFAS coatings with bio-based barriers for paper packaging, for example, and then try to ensure that safety and sustainability goes from TRL technological readiness level 3 to TRL 5 by the project end. Now, this has had, as we are now at month 30 or 31 of the project, a lot of work in the background, but just to show some of the main activities by setting the scene, we try to incorporate design principle in innovation stages right from the beginning. And then following the initial SSBD framework, we had the 5 steps that they are now being replaced by the circular approach of hazard assessment, REACH and CLP mainly, and then moving to worker safety and consumer safety, LCA-based environmental sustainability based on the PEF method and the ISO standards, and then techno-economic assessment, and then try to iteratively use MCDA to integrate the results, which is of course by itself a very challenging point. Now, for those that have read about the scoping analysis of the revised version, setting the scene is probably even the most important part of the application of the framework. So defining the system boundaries, in our case, is cradle to grave for all the applications, so both for bioadhesive and biocoatings. Then we have different functional units depending on the type of product, engineer wood products or paper coated packaging. And then you also have to define the reference scenarios, do primary data collection, and then also use databases for secondary collection. An example is EcoInvent for LCA, but many other databases also for safety assessment. And then two things that we consider very, very important in the application of SSBD for SuperBark is the safety screening tools that have been developed in the very beginning, which is all manual work. There was no automated way to do this screening 2 years ago, and also establishment of data collection templates, both for safety and sustainability, that include a lot of type of informations for all the products that they are under development in the project. Now, here we have listed some of the main achievements, just to show that a research project, in the way that it goes forward from trying to cover a lot of uncertainty in the beginning when the first stages of innovation have many data gaps. Nevertheless, you can gradually increase the granularity, and then once the SSBD plan is made and the data templates are operational, you can do all these activities that you can see here. So for safety, we have been doing identification of hotspots at least twice based on safety screening, and one thing that we consider important is also collaboration between different projects and partners. So we have also, as mentioned by Barry, one of the tools that is being developed in BioPhenom has been used in SuperBark to extend the knowledge base. So except the ECA databases, we have also tried to use OECD databases and also extract information from other sources. And then one of the main reasons to do that is to identify substance and material for substitution, which can be either primary components, solvers, accelerators, and so on. And this is not a one-off activity. It is iterative, and it is happening until the end of the project. Of course, we compare alternatives, and one of the main focuses of SuperBark is on the in vitro testing of the new products. So at the moment, we are planning this activity, because this generates completely new data that is useful not only for SuperBark but also for SSBD in general and the scientific world. Similarly, for the sustainability, we do have intermediate assessments, and with the aim to have a complete assessment of sustainability at the end of the project, to identify hotspots of sustainability, again identify substance or material for substitution, and then compare alternatives to see which possible different routes can be followed. We give here an example about polyphenol extraction. You can use different conditions, and then the environmental impacts of those processes have been estimated to provide information to the technological developers on possible ways to go forward. One very important consideration is that sustainability should always, in our view, be aligned with techno-economic aspects, so that they have the same basis, and then they can be complementary one to the other. And this has been happening consistently in SuperBark. We compare scenarios, and we assess the environmental impacts of the production scenarios based also on the techno-economics, and also try different combination of industrial partners, techno-economic assessment to see the differences in the impacts and the techno-economic outputs. Again, this connects to the techno-economic assessment. You can see that we do that for different scenarios for the industrial partners based on polyphenol recovery and use, integration of different methodologies, including or excluding adhesive and CNF production, in order to see which is the result of the techno-economic assessment and which are the most profitable ways forward. for a company. And then we also estimate the operational costs and production costs for each of these scenarios in order to be able to do cross comparisons and justify assumptions that are being made. Now, of course, it's very difficult to explain in a few words, in a few minutes, sorry, all the work that we are doing, but you can see at least the complementarity between safety, sustainability, and techno-economic aspects and how these can be used for going forward and taking informed decisions. Now, one very interesting aspect of SuperBark is that we also have system dynamics modeling that is trying to provide through mathematical modeling ways to visualize interdependencies between different criteria and then use this information to support stakeholders in taking decisions about technological developments. And then we also go a little bit further, taking recyclability and biodegradability into consideration, both for coatings and packaging paper, but these are very in the very beginning. So hopefully in the next series of webinars where we will have more results, we will be able to provide more information. Now, of course, this is just to give you an overview of how we try to apply SSBD in SuperBark, but we also have many challenges and open questions, and we just place them here for everybody's, let's say, food for thought. As these are constant issues, availability of data, which for SuperBark it is related to component composition, scale-up or pilot data that they are not available always, and desynchronization of SSBD with the innovation speed. Sometimes SSBD is time-consuming to perform, and then the innovation speed is much faster, so there's this misalignment that needs to be taken into consideration. And of course, the inherent uncertainties for the integration of results. You always have trade-offs between functionality, safety, sustainability, and techno-economic aspects, and these have to be taken into consideration. You also have data gaps, and then how to do this integration in a predictive or in a meaningful way remains something that needs to be discussed further. So thank you for your attention. This was all from my side, and I will be happy to answer to any questions at the end of the webinar.
Thank you very much, Panos, for this really excellent presentation and the insights about the SuperBark project. Again, just a quick reminder for the participants that you can type your questions into the chat and we will take them after the next presentation. And with this, I would like to give the words to Elena, representing Unive and the BioSUSTEX project. Elena, the floor is yours for the presentation.
Thank you for the introduction. I hope you can see my slides. Yes, as was said, I'm going to present the BioSUSTEX project and focusing in particular on the methods and tools that we are developing to support the safe and sustainable by design for textiles, because BioSUSTEX aims to reach absolute safe and sustainable bio-based textile. The goal is to advance sustainable innovation for cotton and cellulosic textiles, addressing recycling inefficiencies and harmful chemicals with the technologies tailored to industry needs. As you can see from this slide, the project is structured into 9 work packages. The first 4 are our technical work packages in which we are addressing specific issues in the textile sector. The first one is about pre-processing, so sustainably remove elastane, dyes, and impurities to obtain clean, recyclable cellulose fibers. And then the second one about fiber-to-fiber recycling. A third one about developing bio-based PFAS-free water repellent finishes. And the fourth one about developing removable PVC-free bio-based printing formulations. Then we do have 3 work packages dedicated to the implementation of the safe and sustainable by design framework, focusing on safety assessment, sustainability assessment, and then implementing the different methods and tools into a decision support system to support decisions in the innovation process. Then work package 8 and 9 are focusing on dissemination, exploitation, communication, and coordination. So the leaders of the 3 let's say, evaluation work packages are those that are composing what we call the SSBD team, which is guiding the other partners in the project in the implementation of the SSBD framework to guide the innovation process. So what we included in our project is an integrated pathway from early screening to informed choices for safer and more sustainable bio-based textile solutions. We started with a qualitative life cycle screening assessment. We are now performing in parallel safety and sustainability assessment, and meanwhile we are implementing the decision support system that will be ready later in the project. Going into more details for the qualitative life cycle screening assessment, two methodological approaches were used. The LC-BROM, life cycle-based risk and opportunity mapping method, and the SSBD scoping method developed in collaboration with PARC, the European Partnership for the Assessment of Risks from Chemicals. So as you can see from this slide, we applied the LC-BROM to 3 of the 4 technical work packages that we have. So the one related to pre-processing, the one related to fiber-to-fiber recycling, and the one related to PVC-free print formulation, while the SSBD scoping method was applied only to the work package 3 related to PFAS-free water repellency. Both of them were used to evaluate the technologies that are under development. They are at low TRL in the project across environmental, economic, and social dimensions to support the technology prioritization, the design improvement, and also the SSBD-oriented innovation. I will focus a little bit more on the LC-BROM, as this was developed by 2 partners in our project. So this method follows an iterative approach, which involves the continuous engagement of stakeholders to uncover both the potential risks and opportunities associated with the innovations. The method is actually based on 2 questionnaires, followed by workshops with the innovators and the relevant stakeholders from industry, but also research partners, because we need to understand in depth the new technologies and the life cycle related risks and opportunities. So we started in BioSUSTEX with a stakeholder mapping to ensure representation across the textile value chain. Then an initial questionnaire was distributed to clarify the problem definition, identify also the benchmark technologies, and map also the relevant life cycle stages. Then a kickoff workshop was conducted to refine together the system boundaries, discuss the preliminary responses, and also co-develop the life cycle flowchart for the innovation. Then we had the second questionnaire that was distributed to collect more detailed information on material composition, energy demand, but also toxicity aspects, but, including also perceived economic and social implications. In parallel, a literature review was conducted to contextualize the stakeholders' input within existing life cycle assessment, risk assessment, but also sustainability studies that were relevant for the specific technologies. And here you can see in the slide the matrix that was used to synthesize the information is an expanded MET matrix. So it's including not only material, energy, and toxicity aspects, but also economic and social aspects, dimensions, to identify risk opportunities and also understand the uncertainties across production, use, and end-of-life stages. Here you have also a link to a publication on the application of LC-BROM to work package for PVC-free screen printing ink in BioSUSTEX. Then moving to the safety assessment, where we are conducting it following the first version of the SSBD framework, so step 1, 2, and 3. Actually, we started with hazard assessment, and we are now continuing with human health and environmental risk assessment. So starting with this building exposure scenarios and then integrating hazard with exposure. We are building this work on existing information, but then we are also applying in silico tools and experimental testing when needed. In this slide, I wanted to highlight that there is a strong link in our project between safety and sustainability. And in particular, here I wanted to highlight that safety assessment data are used as input for LCIA toxicity modeling for the calculation of missing characterization factors through 2 tools, ProScale and BioSuStex. And now I will focus a little bit more on ProScale, which is another tool that is further developed within BioSuStex. It's a method providing a hazard and exposure-based scoring system, and the aim of this method is to assess and compare chemical risks of products. So here we have a tool for human health and environmental risk assessment, which is built with a life cycle perspective. As you can see from the figure, it is built in a modular way. And the scores of ProScale can be calculated at different levels of aggregation. So we can consider an entire life cycle, parts of a life cycle, or a specific unit process. To apply this tool, we need to define a functional or declared unit, the life cycle of the product with different unit processes. And in each unit process, the substances used as ingredients produced as products and contained in the product are considered. For each substance and each unit process, the tool combines information about the substance's toxicological properties, so the hazard, the specific exposure determined by the physical properties of the substance, and the defined exposure conditions, including the time of exposure, the population exposed, the quantity of substances used. And this is done for all relevant exposure instances, all substances in all unit processes, so that we are able to obtain a final consolidated score at the required level of aggregation. Here, focusing a little bit more on chemical health risk characterization, you can see that to calculate the scores, we need to consider different inputs, the hazard phrases that we can find according to the CLP regulation, the occupational exposure limits that can be found in national regulations, and the process categories, PROC, as included in REACH dossiers. And very importantly, I wanted to show you that this input data then used to calculate the score, the ProScale methodology that is a function of the 4 parameters that you can see here. So hazard factors related to H phrases and the occupational exposure limits, and then exposure concentration factor, person hours factor, and mass flow. Moving to sustainability assessment, to implement the SSBD framework, we are using life cycle assessment, social LCA, and life cycle costing, which are applied in the project. But then we are also in this case working on methodological development, in this case focusing on absolute environmental sustainability assessment. So this IESA is it builds on the planetary boundaries concept, in which environmental limits are defined as a set of global thresholds. So you can see in the figure on the right, each boundary is defined using pre-industrial Holocene conditions as target levels for the 9 Earth system processes that are included in the framework. And with that value set as the baseline, we can evaluate the extent of human-driven planetary deviations. So the absolute environmental sustainability assessment involves comparing the environmental burdens of individual activities, for example, the life cycle of a product, to planetary boundaries, carrying capacities to understand what it takes for these activities to be environmentally sustainable. So how to proceed in this case? First, we have to estimate environmental burdens. So we apply LCA, environmental LCA. Then we need to allocate carrying capacities. For this, we take the thresholds defined at global or regional level. We have to allocate them, the carrying capacities to the specific activities, to the specific product, for example. And this is the more subjective part of this methodology, as we do not have an exact objective way to do that. There are calculations that are being tested that are based on sharing principles that are derived from distributional justice theories, as for example, the equal per capita or the final consumption expenditure. So we are testing several of them, and of course, the important thing is to be transparent in the choice and compare also the obtained results. Then, I mean, the results of step A and step B are compared to interpret the results, so to draw conclusion on the absolute sustainability of the system. Last part of my presentation is about the decision support system under development in Work Package 7. Here, as anticipated, we expect to aggregate the results coming from the previous steps. So for this, both the safety and sustainability dimension, we will have an aggregation of those results based on multi-criteria decision analysis. We do have some previous and ongoing experiences in implementing MCDA to support aggregation in the SSBD context. Here we're working as CAFOSGRI together with the company Green Decision. Using MCDA because it's a very well established method to support the comparison of different alternatives when we have different criteria, heterogeneous criteria, and we have also to consider different preferences coming from different stakeholders, values, and priorities. We are not starting from scratch in this work because we are basing our work on previous work done in Sunshine project, and now currently in development in the Sunrise projects. We are using a similar hierarchy for the aggregation of the different information and assessment values that we will obtain. And at the end, what we want to have is a tool that is starting from the Sunrise work, but is really tailored to the textile sector, as BioSUSTEX is focusing on this specific sector. So we will have a tool with a database, of course, that will be able to present an assessment matrix in which the different results of alternatives along the SSBD phases are shown in order to support the final decisions by the producers of this of the different alternatives and also relevant stakeholders. So of course, the idea is not to aggregate everything in a final score, but more to show in a map which are the hotspots, let's say, in evaluation, in order to dig into the data and discover which are the causes and ideally improve also or solve these criticalities, these issues. So I conclude with acknowledging the different partners in the project, RISE as coordinator, and then the different universities, research centers, and industries, companies involved in the project. And then I thank you all for your attention.
Thank you very much, Elena. We will take the questions. I will allow just a minute to write questions, probably for Elena as well. In the meantime, just quickly show that this webinar series will have a day 2, the second part. It will be on the 8th of June about circular pathways for bio-based materials, side streams, and end-of-life strategies, with 2 main topics: side streams and end-of-life strategies, 2 presentations for each topic. So we will be expecting you to follow that webinar as well. And now I will take the question. We had so far 2 questions in the chat. One of them is for Panos. How do you handle getting from low TRL data to scaled up process data in SuperBark?
Thank you for this interesting question, which of course it is valid also for BioPhenom and BioSUSTEX and all the projects. So what we try, I don't have a golden answer, obviously, because it is very difficult to deal with low TRL data and scale ups. What we try to apply in a consistent way is to have in the very beginning of the project estimation based on literature data or information publicly available, either from similar processes. For example, when we are talking about LCA, that's why I mentioned EcoInvent, for example, as a very well-known database that is used to simulate similar processes, and then once higher TRL data or scale-up data become available, we rerun the assessments. So if this is related to techno-economics or if it is related to sustainability, it doesn't make a huge difference. The important is to be ready to upgrade and regenerate your results based on more accurate data, so that you have more representative information to be able to decide how to go forward or to see where the developments stand. But again, this is something that it depends on the availability of the scaled up process data, as you mentioned, because in many cases there are some information but not complete, or they are not tailored to the activities that need to be assessed.
Thank you. I don't know if there is anything from Elena and Barry to add, because as Panos mentioned, it's a common problem for all projects.
Yes, maybe I can add a few words. I mean, as I mentioned before, we also, as we are at low TRL, we start with discussing with the partners and relevant stakeholders through questionnaires, but also workshops, because at the first stage we need really to collect all the information that are available to understand the process, the innovation. And then this initial phase is very important also to identify which are the, let's say, best options we have to optimize the process and the product. And then step by step, we are, let's say, identifying which are the few options that we should focus on to perform further assessment. And there we try to put major efforts in generating new data. As I mentioned before, we are also performing experimental work. So we are assessing exposure, for example, for human health and the environment. So also specific analysis. For example, we are now focusing on wastewater analysis for both the industrial process and the end of life in terms of textile. So it's the use and the washing of the textiles by the consumer, and we are also performing ecotoxicity testing. So the important thing is to have a structured, let's say, way to proceed, because of course we cannot put major efforts on all the initial alternatives, but we have to go step by step in an intelligent way, let's say, in order to focus our main efforts on the most promising solutions. And this is really requiring a lot of work and iteration of the process, but we see that it's working when all the parts involved in the project are aware aware of the final goal and also of the process that we are following, so the implementation of the SSPD.
Thank you. And don't know if there are any other questions. Not in the chat. There was a question, but Panos answered it via the chat. So if no other questions, I would like to thank you very much for your participation. A big thank you for our 3 speakers today. Thank you very much for the insights about your project. And then, as I mentioned, we are expecting with all of you for the next day of our webinar series, which will be on the 8th of June. The recording of the presentation will be soon, later today, available on the BioPhenom website and will be shared also on LinkedIn. So thank you very much for the participation and have a nice rest of the day.
Thank you for the invitation.
Bye-bye.
Thank you all.
Bye.
Bye.